Okay, in this video, I would like to show everyone more on the Model T Ford charging system at Coral Castle that Lead Scallons got set up. Let's get in this video. In my last video, I left off at the black box pretty much, and we're going to go into this and what it's doing, because at this point, we are going from AC, from what the flywheel is producing naturally, to running it pulse DC from this black box. Okay, the black box is the points and condenser system for the ignition for the Model T. And this is where all the dielectric is being stored. Okay, all the dielectricity is being stored in this box. So what we're after is this. We're after the DC. Or you could call it direct current or direct counter space, because it's the same thing. It's an impulse frequency that doesn't have modulation. It's kind of complicated, but this is what it's doing. It's doing these wave spikes, and this is Tesla scalar. It's measured in decibels per second or volts per second, and this is what we're after. So let me show you how Lead Scallon's accomplishing this. Okay, so when the system is spinning, those V magnets are doing the Fibonacci, and they're creating the 1.618 forever opening spiral. So it says here that okay, so Ed used a 1908 Model T Ford. It had no battery, no dynamo support. Here's another one of his Sweet 16s, 168 miles per second, which is the rotation of the Milky Way. And it's also his 16 V magnets in the Ford. The Sweet 16 is the cryptogram. It's Agnes leaving out the first M and the sixth T in magnets. That'll leave you with Agnes. So that was supposedly his fiancée that jilted him. Okay, Agnes is the Model T Ford Magneto. The flywheel separates electricity from magnetism. Is how it's pointing this out. Okay. And then here's the dollar speed of waveform. Pi by 2 times C. And you get your 291,000 miles per second. Okay, so the waveforms from the moon are longitudinal. Okay, this is your whole deal, your longitudinal, your dielectric. The magnetic system builds up a dielectric charge, and then the electromagnet sits next to the flywheel, and alternates at high speed. Dielectric is stored in the ignition system, and instead of the spark plug providing 20,000, instead of a spark plug, it's providing an impulse of 20,000 volts to an electromagnet. Okay, so this is the whole deal on how Ed's doing this. He's got this thing doing this. This is what I need to point out here. Remember, I showed you that this whole deal with the radio frequency and the RF and the AC. Okay. RF has the same fingerprint as AC high voltage. RF current, or RF at high current frequency, high frequency, there's no resistance. So when you go into this electrical book, this is what it's showing you. This is what Ed's doing right here. He's doing a man-made lightning bolt. His whole ignition system is the cloud. It's storing everything right here, and it's blasting the dielectric discharge. This is how it's working. He's getting a lot of power, and he's got different ways of gaining power. It's not losing anything in the system. He's using everything that's being generated, and I'll show you what I mean. Okay. Average values of voltage and current are actually DC values. The average value must be found when a sine wave AC voltage is changed to DC with a rectifier. The rectifier is shown as a bridge type rectifier that produces full wave rectification. This means that both the positive and negative half of the AC waveform are changed into DC. This average value is the amount of voltage that will be indicated by the DC voltmeter if we're connected across the load of the resistor. Okay, so what it's showing you is that the AC is being transformed or being rectified by that commutator. So it's switched to DC. So what it's doing now is the current, the average voltage is proportional to the peak or the maximum value of the waveform and to the length of time it is on as compared with the length of time that is off. So here's your pulse, here's your on and off, your 1 and your 0, your switch. That the voltage waveform is turned on and off, but it never changes polarity. The current therefore never reverses direction. This is called pulsing DC. The pulses are often referred to as a ripple. This is what I'm talking about. Here's your scalar, here's your ripple. So it's instant, okay? It's pretty funny too because this whole electrical book right here, standard college textbook, shows you exactly how to do the Philadelphia experiment, the Hutchinson effect, and the Leeds-Skalman effect all in one. Right out in the open. They show you how to do this if you know what you're looking for. Let's continue. So, okay, here's your regular sine wave and what it's doing, and then here's your pulsing DC and how this thing is operating. So what I'm getting at here is when the current flows through a conductor, a magnetic field is created around the conductor. When high-frequency AC is used to produce a magnetic field, the field will rotate away from the source at the speed of light, 186,000 miles per second. Wavelength is a distance the radiating field or signal can travel during one cycle of alternating voltage. The wavelength is generally represented by the Greek letter lambda and can be computed using the formula. Okay, the speed of light in meters per second divided by the frequency. Okay, so this is how it's, what I'm saying is the RF has the same fingerprint as AC high voltage. Radio frequency current at radio current at high frequency, there's no resistance. So this is what Ed's wheel's generating. Right here, it's doing this. High frequency AC causes a magnetic field to rotate at the speed of light. So his whole wheel is producing this like a broadcasting station. So he's not losing anything on his system. He's getting his power and he's getting this effect out of it. So this is what I want to point out and how this whole thing is working. It's pretty amazing what Ed has figured out how this thing works. He's actually got this whole thing, okay, when you have this thing called the Crystal Detector. It's an electromagnetic component used to rectify radio alternating current using asymmetrical conduction of crystals discovered in 1874, first used to receive radio waves in 1894 and improved in 1904. The crystal detector was the first semiconductor diode and one of the first semiconductor electric devices. The crystal radio, its function is to rectify the radio signal, converting it from AC to a pulsing DC to extract the audio signal modulation from the radio frequency carrier wave. It can also use a battery-operated buzzer to generate and test signal when rectifying spot has been found in the crystal. A buzzing sound is heard in the earphones. The crystal conducts current only in one direction, stripping of the oscillations on one side of the signal, leaving a pulsing DC, whose amplitude does not average zero but varies with the audio signal. A bypass capacitor across the earphone smooths out the waveform, removing the radio frequency carrier pulses, leaving the audio signal. This is why Ed had a room set up in Coral Castle that he called the repentance room, but it's really the resonance room. He was listening for that buzz. Okay, so I think I'm going to stop my video here, and we'll continue as the connection daisy chains down the line. And I'm going to show you exactly how Ed was doing what he was doing. Thanks for watching.